Assalamu alaikum. I'm Safa Ali, and the topic of my presentation is size reduction. So, firstly, let's discuss about the contents that we will see here. Firstly, we will see what is size reduction. Then there will be the objectives, that why we use this process. Then there will be the factors, advantages, disadvantages, and at last we will see the equipments that are used for this process. Here is size reduction. It is basically a mechanical operation. The term size is referring to dimensions of an object, and the term reduction, as we know, refers to decrement or decreasing of size. Therefore, we can define it as the process of converting the object from one physical dimension of higher order to smaller ones. In other words, we can also say that we have to convert the size of bigger particles to smaller ones by using external force. There are also some other terms that are used for the same purpose that are named as cumination, pulverization, and diminution. All of the three terms refer to size reduction due to the similar meanings. So let's see them one by one. Firstly, we have cumination. As I have earlier explained, that it is the generic form of size reduction having the same meaning. So what we do in this process, we take a metal rock and we convert it into a powder form by using the external force. As we are using the external forces here to convert the material in powder form, so it is obvious that there must be the three major things that would be required over here. That will be cutting, crushing, and grinding. They will convert it into the smaller pieces and then into the powder form. Then there is diminution, that also refers to the same meaning, showing reduction in size. Now there is last term, that is pulverization. It refers to crushing of the material into the powder form. And if we move toward the other meaning, then we can also say that it has the meaning to be demolished down. For example, if we talk about a building, when it is torn down, then the process involves the concept of size reduction, because we are converting the whole building into the smaller particles. So I'll summarize by saying that all of the three words are synonyms of each other because they have the same meaning for size reduction. Now you can see here in this diagram, there is a bigger particle, and when we apply external forces, then we can convert it into the smaller ones or into the powder form. And the external forces, as I have earlier explained, that maybe any other mechanical external force that can be cutting, grinding, crushing, and whatever you can use. So next, there are objectives. In objectives, I'll explain to you why we use this process and why we are converting the larger particles to smaller ones. So we can see if we carry out any process, whether in the laboratory or at any other way, then we see that the smaller particles are easy to handle as compared to bigger ones. The main reason is also that their dilution becomes more easy. So first purpose is to convert the bigger particles to smaller ones, due to which their surface area is increased. We can also achieve the proper mixing, and the handling of the powder can also be improved. Then the absorption also improved due to the smaller size, obviously, and then and then there will be the increase in physical stability, due to which the flow of powder will be increased. So this was all about the objectives, that why we use this purpose. Now there are factors affecting that affect the size reduction. Firstly, we have hardness. As we know that the bigger particles are not much easy to break as compared to the soft ones. So hardness also affects size reduction. And if we talk about toughness, then the fibrous nature having high moisture content, they are tough in nature. So soft poses a problem than hard brittle. Then there is stickiness. The stickiness process, then if the material is being sticking, then the whole machine or the process can damage down. So this should be avoided, and complete dryness can overcome this problem. So there should not be the stickiness in the material. The next one is moisture content. As we also use the grinding in this process, so moisture is also involved. Therefore this we have two conditions here. If we are doing the dry grinding, then there should be the 5% moisture, and if we are doing the wet grinding, then there should be the 50% moisture, because in grinding there is necessary that moisture should be present, otherwise the grinding would not be carried out. Then there is softening temperature. If we talk about the waxy substances, for example, stearic acid or drug containing compounds, then they become soft when their heat is produced. Because this process of size reduction is heat producing, as we are applying here the external forces. So due to such forces, the heat can be produced, and this heat can create the problems for the substances that is being reduced. So to overcome this problem, we can put the whole process or machine into the cooling. So here softening of the temperature is also required. Then there is purity. Purity is required because mills should be cleaned properly, otherwise different problems are created in the uniformity process. As we see that if the mills are not cleaned properly, then we shall not get the 100% results due to the impurity added. So purity is required here greater. Then there is material structure. Then if we talk about the mineral substances, they can produce the Higgs here. Next one is ratio of feed size to product size. So it is clear from the above discussion that if the size of the feed is small, then we can easily get fine powder, and if the size will be larger, then we can get the problem. So small size will be easier. Then there is bulk density. So as we know that density involves mass and volume here. That is the major characteristic of any material. So output of any size depends on the density majorly. These were all factors affecting this process. Now we move toward the advantages. So from above discussion, we can easily say that from this process we can get the contact uniformity, uniform flow, effective drying is also obtained, uniform mixing and drying can be obtained. At last, we can also improve the rate of dissolution due to the smaller size, so absorption will be increased. There are also some disadvantages of this process, as I have earlier explained that the heat is produced in this process, because we are using here the external forces due to which heat can be produced. So this can create the problem because heat building during the milling is more, so product can be degraded, and this is not good for the process. And if we talk about the hammer mill, this is the equipment that is used for this process. So in hammer mills, the hammer mills cannot be employed to the mill sticky, because the fibrous and the hard materials as their screens can be clogged. So this is the disadvantage, and we have to overcome this problem so as we can easily carry out the whole process. Then there are methods of size reduction. Normally, size reduction can be achieved by two methods. First one is precipitation, and second one is mechanical process. Mechanical process I have earlier explained above the diagram, and if we talk about the precipitation method, then basically in precipitation, the substance is dissolved in appropriate solute, and it is used to reduce the raw material and the bulk products. So next, we have the equipments that are used for this purpose. There are many equipments that are used for size reduction, but the main equipments that are mostly we are using in the industries, for example, in pharmaceutical industries. So that these are ball mill, hammer mill, cutter mill, roller mill, and fluid mill. These are all equipments that are used for this process. Firstly, let's take a look about ball mill. Basically, it grinds the material by rotating a cylinder with steel grinding balls, and that will cause the balls to fall back into the cylinder. In this way, they will be grinded, and the rotation will be between 4 to 20 revolutions per minute. In this diagram, you can see, as I have told you earlier, that it consists of the cylinder that is made up of the steel, and we put the material into this cylindrical into this cylinder. So when the cylinder moves due to its revolution, the material will be grinded, and it will move on to each other, due to which the material will be grinded. So this was all about the ball mill. Now move towards the hammer mill. You can see over here its diagram, and hammer mill consists of a central shaft to which 4 hammers are attached. And these 4 hammers are next attached to the swivel joints that will help the hammers to swing out about the radical position. And there is the lower part that is containing the screen over here. And this screen can help the material to escape out. This was the second one equipment. Next is cutter mill, as the name is suggesting here that we cut the material here with the help of the knives. So here the size reduction involves successive cutting or shearing the feed material with the help of sharp knives. As here you can see, we have the knives that are cutting the material, and at last there is the screen that is escaping the material. In this way we can reduce the size of material as we easily can handle. Then there is roller mill, and if we talk about, then it uses the cylindrical rollers either in opposing pairs to against flat plates. So crushing of the various materials can be carried out, for example grain or gravel and plastic can be crushed out with the help of this mill. And these mills are also the alternative to the traditional millstones arguments in the grits mill. This is the diagram of roller mill. We can see here that there are 2 rollers, as I have already explained, to the opposing sides of each other. So when the feed is put over here, then they can be converted into the smaller size with the help of these rollers. Next one and the last is fluid energy mill. It is also named as the jet mill and microfibers or ultrafine grinder. So material is reduced by attrition and impact here. The feed is torqued and suspended within a high velocity airstream, and the milling takes place due to the higher velocity collision among the suspended particles. As you can see over here, when the particles are suspended over here, they have the higher velocity, and due to their higher velocity, there will be, due to their higher velocity, there will be the collision among them, and due to this, they will be converted into the smaller particles. And basically, it is used to reduce the size of antibiotics and vitamins. So this was all about my presentation, where we discuss about size reduction and all its equipments, objectives, advantages and disadvantages. Thank you.